Hello everyone. So today's topic for the lecture is hypothesis testing. That is in two ways we go for the hypothesis testing. One is parametric approach and another is non-parametric approach. Under parametric approach also we have several techniques. You can say algorithms also. And under non-parametric approach also we do have some different techniques. So from the very beginning, we'll go through a few important points, or both of them, that means parametric and non-parametric approach, and we'll pick up one important technique from each of them. Okay, so let's start then. Well, then the title of this lecture is Testing of Hypothesis, Parametric and Non-Parametric Tests. And this is the last topic of your syllabus, unit number 4. Okay, so we all know about hypothesis and the importance of hypothesis in any research, in any planning, of course, right? And we also go through the different types of hypotheses in one of our previous lectures. You all attempted them. If anybody missed that, then you will find that in the playlist. Go through it. Well, so hypothesis testing is one of the most important concepts in statistics. Here, the statistical tests are used to check whether the null hypothesis is rejected or not rejected. Okay, to remember, or you can say recall the null hypothesis and alternative hypothesis definitions, right? So with hypothesis testing, we try to check whether the null hypothesis can be rejected or not. This statistical test assume a null hypothesis of no relation or no difference between groups. Now look at this diagram. I hope this figure is visible to you. Hypothesis, null hypothesis, and alternate hypothesis, right? Now, hypothesis testing is mainly targeting which one? That is null hypothesis, right? Got it? Hypothesis testing is mainly targeting the null hypothesis. Now, in hypothesis testing, I told you that we use some statistical test, and that test either parametric or non-parametric. In parametric test, as I have said you that there are several different techniques like Z-test, T-test, F-test, ANOVA, and in non-parametric tests also we do have some test techniques like chi-square test, U-test, H-test. At least you should know that which one belongs to parametric or non-parametric. Okay. So as usual, I'm going to ask few questions throughout the class, and you need to answer the questions through comments. So let's move ahead. Let me clear the screen. Parametric test. The basic principle behind the parametric test is that we have a fixed set of parameters that are used to determine a probabilistic model that may be used in machine learning or whatever your area, right? As I am from machine learning, I should be, I already know that my area of specialization is AI, machine learning, computer vision, right? Artificial intelligence. So that's why I'm citing this. You should cite one specific area from your domain. So let's again read the definition, means principle. The basic principle behind the parametric test is that we have a fixed set of parameters that are used to determine a probabilistic model. Right? Probabilistic model, you know now. Okay, we discuss it. So that probabilistic model, we are going to check it, means with respect to some parameters. Now, these parametric tests are those tests for which we have prior knowledge of the population distribution. You may note it. These tests are for those where we have some knowledge, we have prior knowledge about the population distribution that is normal, or if not, then we can easily approximate it to a normal distribution, which is possible with the help of some theorem like central limit theorem. Now, parameters I have mentioned here, right? What are they? Like mean, standard deviations, they will be the parameters for using the normal distribution. Eventually, the classification of a test to be a parametric is completely dependent on where the population assumption. Now, this parametric test available for some sort of tasks, like to find the confidence interval of the population, means with the help of non-standard deviation, right? What is standard deviation? So now standard deviation is being treated as the parameter to determine the confidence interval for population, means along with the unknown standard deviation, to find the confidence interval for the population variance, to find the confidence interval for the difference of two means with an unknown value of standard deviation. See, everywhere we are using the parameter. What? Parameter means that thing based on which, based on the value of which this model will be checked, right? So that is standard deviation here. Now, some very common examples of this parametric test are t-test, z-test, f-test, and ANOVA. T-test. As I have told you that I'm going to pick one of them and I'll explain that. Now, from the parametric test, I'm picking this t-test. T-test, it is a parametric test of hypothesis testing based on students' t-distribution, essentially testing the significance of the difference of the mean values when the sample size is small. Remember, where we are applying this t-test? When the sample size is small and when the population standard deviation is not available. So what are the assumptions that we have to make for this test? First one, population distribution is normal, samples are random and independent, and the sample size is small, and population standard deviation is not known. I'm repeating again, these are the assumptions that you have to make for t-test. First, population distribution is normal. Second, samples are random and independent. And the third, most important one, that is the sample size is small and the population standard deviation is not known. Okay, so at least write these assumptions of the t-test. Okay. Then Mann-Whitney test is a non-parametric counterpart of the t-test. तो आप लोगों को एक MCQ टाइप के क्वेश्चन में पूछ सकते हैं कि व्हाट इज द नॉन पैरामेट्रिक काउंटर पार्ट ऑफ द टी टेस्ट. नॉन पैरामेट्रिक क्या है अभी मैं बताऊंगा. मींस ये जो टी टेस्ट है, दिस इज अ पैरामेट्रिक टेस्ट. नाउ आपको क्वेश्चन में पूछ सकते हैं कि व्हाट इज द नॉन पैरामेट्रिक काउंटर पार्ट ऑफ टी टेस्ट फ्रॉम द फॉलोइंग. इसमें नीचे आपको ABCD ऑप्शन में दिया रहेगा. तो अगर ये दिया हुआ है Mann-Whitney test, then this is a non parametric counterpart of the t test. So the formula that we use here is T x bar minus mu, right? So where x bar is the mean of the sample, mu is the assumed mean, and this is the obviously standard deviation. This symbol you all know. Then divided by this root over n. What is the n? N is the number of observation. Yeah, you can see that this formula is easy to remember, right? So that's why we use this test frequently. One example means one more reason for that. So you can note down this formula, very easy, right? X bar minus mu divided standard deviation divided by root over number of observation. ठीक है? T-test समझ में आ गया सबको? You all got it, T-test. ठीक है? Now, first question of this today's lecture is that you are going to write the assumption that to be made for t-test. You are going to answer this question by comment. Now coming to the next, that is non-parametric test. In non-parametric test, we do not make any assumptions. ठीक है, तो आप लोगों को अभी मैंने बताया पैरामेट्रिक में हमने क्या किया, एक assumptions लेके चल रहे थे, राइट? आप assumptions मतलब कुछ कुछ assumptions लिया था, उसके बेसिस पे मैंने आपको दिखाया कि टी टेस्ट परफॉर्म कर रहे हैं और उसमें पैरामीटर लिया था स्टैंडर्ड डेविएशन. अब नॉन पैरामेट्रिक टेस्ट का फर्स्ट पॉइंट ये है कि we do not make any assumptions about the parameters for the given population or the population that we are studying. So that's why this is clear that this test is not going to depend on the population. देखो ये second point है, आपको note down करना है कि what is the difference between, questions may come that what are the differences between parametric and non-parametric. Now here you have seen that we are not making any assumptions, right? And second, that it is not going to depend on the populations. ठीक है, तो ये समझ में आ गया? Is this clear? Okay. ठीक है, तो नॉन पैरामेट्रिक में हमने देखा कि ये कोई भी पॉपुलेशन साइज के ऊपर और यू कैन से पॉपुलेशन के ऊपर ही डिपेंड नहीं कर रहे हैं. सो देयर इज नो फिक्स सेट ऑफ पैरामीटर्स अवेलेबल एंड आल्सो देयर इज नो डिस्ट्रीब्यूशन ऑफ एनी काइंड इज अवेलेबल फॉर यूज. ठीक है, पूरा पॉइंट्स, all the points, kindly note them down. This is also the reason that non-parametric tests are referred as distribution free test. क्योंकि ये distribution के ऊपर depend नहीं कर रहा है, as it is not depending on the distribution, right? So that's why non-parametric test is also referred as distribution free test. Okay, so modern days non-parametric tests are gaining popularity and an impact of influence on why this is getting so much popularity. Some reasons are like, main reason you can say that there is no need to be mannered while using this parametric means test, means, or you can say non-parametric test, of course यहाँ पे non-parametric होगा. The second reason is that we do not require to make assumptions about the population given on which we are doing the analysis. ठीक है, easy है तो फिर then most of the non-parametric tests available are very easy to apply and to understand also. So if we compare this parametric and non-parametric, so then what you get, that non-parametric is easy to means employ, right? Complexity is also very low. Now some very common examples of frequently used non-parametric tests are chi-square test, Mann-Whitney U test. I have just mentioned you that Mann-Whitney U test is the counterpart of the parametric test t-test, right? Kruskal-Wallis H-t test. Now, as I have said that why I'm going to pick up one of them. So here I'm picking up which one? This one. Okay, chi-square test. Chi-square test, a non-parametric test, and it is used for what? Test of goodness of fit as a test of independence of two variables. Two variables का independence कितना है वो भी टेस्ट करने के लिए हम क्या यूज कर सकते हैं? chi-square test. It helps in assessing the goodness of fit between a set of observed and those expected theoretically. What you observe, what you were expecting theoretically. So if we try to measure the goodness, right? So then this test will help you for that. It makes a comparison between the expected frequencies and the observed frequencies. ये line समझाने की जरूरत नहीं है. You got it that it is helpful. Means with this test you can find a fitness between these expected frequencies and the observed frequencies. And whenever difference is greater, the greater is the value of chi-square. Second question of this class is that if the difference here is greater, whether the chi-square value will be less or greater. Okay, comment the answer. Okay. If there is no difference between the expected and observed frequency, कोई difference ही नहीं मिला, this means the chi-square value will be what? If there is no difference, then the chi-square value will be 0. ठीक है? It is also known as goodness of fit test, which determines whether a particular distribution fits the observed data or not. And the formula is, this is the formula where this O is the frequencies observed and E is the expected frequency, and this obviously is the sum. Okay, O minus E whole square divided by E, and you make a sum of it for the number of observation. So this is the square or chi-square value. So this value will determine the goodness of fit, right? That's why this chi-square test is also known as goodness of fit test. As I already mentioned you that this is used to test the independence of two variables. Some conditions are there for this test. Randomly collect and record the observation. In the sample, all the entities must be independent. No one of the groups should contain very few items like less than 10. देखो उससे उल्टा हो रहा है, ठीक है? यहाँ सैंपल थोड़ा हम बढ़ा ले रहे हैं. The reasonably large overall number of items, normally it should be at least 50. However, small the number of groups maybe, but we generally target large. Okay, these are the condition of chi-square test. So coming to the end of this lecture, before ending the lecture, I again want to ask you a few questions. Next question is, first part of the next question is that what are the other name of t-test and chi-square test, and what are the reasons that they have been named like that? Okay, and next question is that, second part of this question is that what are the conditions for chi-square test and why we are calling it as a non-parametric test? So सारे क्वेश्चंस का आंसर दे दो, ठीक है? तो इससे आपको ये जितना भी आइडियाज है और एक बार रिवाइज हो जाएगा. And if any part of the lecture you find difficulty, you again attempt it and you may ask me for comment also, but don't forget to or don't skip the answering of the questions. ठीक है? और एक चीज मैं बोलना चाहूंगा कि जो एनोवा टेस्ट है, आप लोग एक बार काम करो, you go through the ANOVA as a home assignment. ठीक है? So if you don't get it, then obviously I'll take a lecture on that. ठीक है? So I think that whatever the topics I have discussed today is clear to you, and I also think that this way of talking with you through comments and this way of delivering lecture is helping you to revise the topics, because in the lecture you can pause and you can again rewind or forward, right? Rewind the topics that you want to listen again, you want to understand again. So that's it. We'll meet in the next lecture. Till then, take care. Bye bye.